The last half of section 11.1 is on a process called completing the square. And in order to do this, we need to review something that you may have let slide when we studied factoring. Okay, and I let it slide myself. Perfect square trinomials. Perfect square trinomials look like something like x squared plus 10x plus 25. What are their characteristics? Well, the first term is a perfect square. The last term is a perfect square. The middle term is 2 times the product of their square roots. Okay, so if I ask you to factor this, what's the square root of x squared? X. We're always going to keep the sign from the middle term. And what's the square root of 25? 5. Now, you may not have done it that way. By the way, when you check it, what's this product? 5x. Is the middle term twice that? Okay, then that's the right set of factors. Most of you probably did it as trial and error, and you got x plus 5 times x plus 5. But it's going to be important in this lesson that you recognize perfect square trinomials. Perfect square, twice the product of their square roots. Okay, let's look at another one. Suppose I have x squared plus 20x plus 100. All right, is this a perfect square trinomial? Is this a perfect square? Is the last term a perfect square? Okay. Is the middle term twice the product of their square roots? Now, sometimes you have to sit here and play with it a little to answer that question correctly. Take the square root of that one for x. Take the square root of 100 for 10. Take the sign from the middle. And then always double check. What's this product? 10x. Is the middle term twice that? Then those are the factors. Now, the fact that I was able to make up perfect square trinomials without a list of them sitting here doesn't mean I'm brilliant. It means that I know some characteristics, and you're about to know the same characteristics. What we're going to do is do a process called completing the square, which means I'm going to get the beginning of a perfect square trinomial, but I'm going to have to complete it. All right, I'm going to pause this for just a second. Can't do it. Okay, completing the square. If I have an x squared plus, let's say, 40x, and I want you to complete this so that it is a perfect square trinomial. Somehow you've got to figure out what number should go here so that this becomes a perfect square trinomial. Okay, first of all, the coefficient of this x squared term needs to be a 1 for this to work, and it is. Here's how you figure out what number goes in here. You take the middle term's coefficient, 40. Do you remember that it's twice the product of their square roots? And if that's a 1, then it doesn't really even count. So I'm going to take half of it, I'm going to multiply it by half, and that's going to give me 20. Then I'm going to take the 20 and square it. And that's going to give me, in this case, 400. Let me put 400 right there. If the middle term is 2 times the product of their square roots, 2 times square root, I'm going to do exactly the opposite. Instead of 2 times, I'm taking a half. Instead of square root, I'm squaring to go back and create that. If that number's right, then what will be the factors? Well, what's the square root of x squared? X. Keep the sign from the middle, plus, what's the square root of 400? 20. So we're going to do two things. We're going to create the number that will complete a square, and then we're going to factor it. And you'll see why in just a minute. We need to practice this just a little bit more. Let's suppose we have x squared plus 8x plus blank. And I want you to fill in the blank so that it is a perfect square trinomial. All right, how do we do it? We take this number, 8. What do we do with it? Take half of it. Half of 8 is 4. Then square that for 16. Send that number back up here. It will be a perfect square. Can you factor that now? What will the factor be? X plus 4. So you can always take the square root of the first number, take the square root of the last number, sign from the middle. And by the way, the number that goes in there, right there, is always sitting over here as half your number. Okay, let's do a couple of others. Whoops. Didn't mean for that to go. Let's look at x squared minus 7x, and I'm going to ask you to complete the square. This one's not as friendly. I take the coefficient, -7. I take half of it. Well, the reason it's not as friendly is that it's not an even number. So, do y'all agree that I will get -7/2? Then I'm going to take -7/2 and square it. What will that give me? 49/4. That's the number that I put in here to complete the square. I've done the process of completing the square. Next question, what will the factors be? X, it'll be minus this time, and anytime if you have trouble, look right here. The number is sitting there, and hopefully you even have the correct sign on it. It is x minus 7/2. Now what I need to show you is how this helps you solve an equation. Okay? This is completing the square. You had to recognize what a perfect square trinomial is and be able to complete it if it wasn't already one. All right, I've left myself a little workspace between each one of these problems, and each one of them says solve the equation by completing the square. So this is 11.1 part 2. All right, suppose I have x squared plus 8x is equal to -7. Let me say a couple of things about format. Format for factoring. Everything on one side, 0 on the other side. Format for perfect square, for taking the square root property. Square on one side, number on the other. Well, what's the format for this? The format is you're going to have the x squared term, the x term on one side. You're going to have the constant number on the other side. And by the way, completing the square process is outlined on your blue sheet, on the note sheet. The coefficient of the squared term has to be a 1. If it's not, you're going to have to divide by it. But you'll see that as we move through. Problem number 1 is completely ready for completing the square. Coefficient is 1, got my squared term, my x term over here, got my constant over here. The next thing I'm going to do is write x squared plus 8x plus a blank so that I can complete the square equals, well, this is an equation. So if I put a blank on the left side, I need to put a blank on the right side. Is that okay? Now, I'm going to take the coefficient of x, which is an 8. And what am I going to do? Okay, I'm going to take half of it, and that gives me 4. And then I'm going to take that 4 and square it to get 16. 16 is the number that I put in the blank to complete the left-hand side into a perfect square. But since this is an equation, if I put a 16 on the left, I have to put a 16 on the right. Yes. It's always, when you put it into the blanks, it's always positive because it's the square of something. Okay? Now, if you did it correctly, then on the left-hand side, you created a perfect square trinomial. And if I factor that, what will the factors be? X plus 4. And once again, the number that needs to go in here should be sitting there if you write down the steps kind of like I do. On the right-hand side, I don't know what you'll get. You'll get something. What's negative 7 plus 16? 9. Now, I haven't said this was going to happen, but it is going to happen every time. What does the problem look like now? Yes, it looks like, I hope, square root property. When you complete the square and you do your factors on the left-hand side, you create a square, and you should have some number on the right-hand side. So this should now be square root property. Take the square root of the left side, x plus 4 is equal to plus or minus the square roots of 9. Do you know the square roots of 9? Yes. So it's x plus 4 is equal to plus or minus plain old rational 3. Subtract 4 from both sides, putting it in front. X is equal to negative 4 plus or minus 3. Now, this is one of the problems where you're going to get two different rational answers. Because I literally can do the addition and subtraction. I have negative 4 plus 3, which is negative 1. And I have negative 4 minus 3, which is negative 7. When you take the square root of the right-hand side and you get rational numbers, that means that you're going to be able to do all the arithmetic and get two nice rational answers. What it also tells you is that if anybody had allowed you to, this original problem was factorable. Now, factoring, I think, is easier. So I'm going to take just a minute and take this problem and go up here and just show you. This was x squared plus 8x equals negative 7. Now, you didn't have a choice. You were told complete the square. And so we were good people and we did what we were told. But what if you weren't told? What if you were just instructed, solve this thing any way you can? You look at it and you go, well, it's quadratic. I think I'll set it equal to 0. So x squared plus 8x, add the 7, plus 7 equals 0. Oh yeah, I think I can factor that. You need a plus and a plus, an x and an x. Do y'all agree 7 and 1 are your only factors? Do those add up to be 8? Yes. So 0 factor property says x is negative 7, x is negative 1. Did I get the same two answers? Yeah. Factoring, in my opinion, is the fastest method of all the methods for solving quadratics. The problem is it only works when the answers are rational. So it worked beautifully on this problem, but we're going to look at some where it wouldn't have worked at all. So when you get to college algebra, where I assume most of you are going, you usually will be given complete freedom. Solve this quadratic by any method that you have at your disposal. Personally, I always try factoring first. And if it doesn't work, I go on to another method. So I have to force you to use all the methods, even when you don't want to. All right, moving on to problem number 2. Problem number 2 also says in its instructions to solve by completing the square. So that whether we want to or not, whether it's factorable or not, we have to solve this by completing the square. So let me get some room. I have x squared plus 4x plus 2 equals 0. And by the way, it's not factorable. You could never get the factors of 2 to add up to be 4. So I couldn't factor this, so it's a good thing I'm learning another method. Is this in the right format for completing the square? No, I need the x squared term with a coefficient of 1. I need the x term, but where does the constant need to go? Other side. So I would need to subtract 2 before I can even get started. I have x squared plus 4x is equal to negative 2. And because there are a lot of steps in this, that's why if you look at your blue sheet, you'll find these steps outlined. All right, the left-hand side is x squared plus 4x, and I'm going to need a blank so I can complete the square, equal sign, negative 2 plus that same blank. Grab the coefficient of x, which is 4. Take half of it, which gives you 2. Take the 2 and square it. I'm back to 4. So what goes in my blank? 4. I have finished the job of completing the square. And it's very formula. Take that number, take half of it, square that, you got it. All right, the next job is to decide what the factors are. And what would they be? X plus a 2. The right-hand side, you just get whatever the sum of those numbers is, which in this case is 2. And I hope that you always recognize at this moment that you've just created a problem where you can use the square root property, which actually is why we study the square root property. All right, that's going to give me, using the square root property, x plus 2, oops, I don't need parentheses anymore, is equal to plus or minus the square roots of 2. Can you simplify the square root of 2? No. So just subtract this 2 from both sides, and x is equal to negative 2 plus or minus the square root of 2. Can you add these up and subtract these to get 2 nice answers? No. Now my math lab, once again, would want negative 2 plus the square root of 2, comma, negative 2 minus the square root of 2. Those are your 2 answers. The process okay? All right, let's look at number 3. I have x squared plus 3x minus 3 is equal to 0. I'm supposed to, by the instructions of the problem, use completing the square. Is it in the right format? No. So I'm going to have to add 3 to both sides to get that constant over to the other side. So I'm going to have x squared plus 3x is equal to 3. I'd like to put my blanks in. That's x squared plus 3x plus a blank is equal to 3 plus a blank. Let's take this coefficient, which is a 3, take half of it. Now please don't go into decimals. It will just cause you grief. I'm going to live with the fractions. 3 over 1 times 1 over 2 is 3 over 2. Then I'm going to square it. 3 over 2 squared, square the top, square the bottom. That gives me 9 over 4. And stop me if you have a question about those numbers. All right, the number I need to complete the square is 9 over 4. 9 over 4. The square's been completed. It's time to decide on the factors, and they're going to be easy, even in the case of fractions, because the number you're looking for is sitting right here. It's going to be an x. That's a positive 3 over 2, so it's a positive 3 over 2. Whoa. Sorry, thought that had changed. Now, the right-hand side can be a fraction problem, and it is. I need to add 3 to 9 over 4. So we're going to do that. I'm going to draw a little spot over here to do it. I've got 3 plus 9 over 4. Well, that's really 3 over 1. What's the common denominator? 4. 1 goes into 4 4 times, and 4 times 3 is 12. Do you agree that 12 over 4 is 3? Okay. The other fraction does not change. So I have 12 over 4 plus 9 over 4 gives me 21 over 4. Okay. So you might have to do that kind of arithmetic. But even if you do you recognize that you just created square root property problem? All right, so I have x plus 3 over 2 is equal to plus or minus the square root of 21 over 4. Not a lot of fun, I know. When we dealt with radicals, do you remember that we had this rule that said don't leave a radical in the denominator? Rationalize it if you need to. Well, this is the square root of 21 over the square root of 4. So is it going to be hard for us to come up with a rational number to put here? Or do we know what the square root of 4 is? We know what it is. It's 2. So this is x plus 3 over 2 is equal to plus or minus the square root of 21. You notice that the radical got short just over the 21. It's not over 4 anymore. It's over plain old rational 2. Am I finished? Does it say x equals yet? Now I've got to subtract 3 over 2. Subtract 3 over 2. That's going to give me x is equal to negative 3 over 2 plus or minus the square root of 21 over 2. It will happen almost always that the two fractions you get will have the same denominator. So since they have the same denominator, I typically write it only once. -3 plus or minus the square root of 21 over a single 2. And those are my answers. This certainly was not factorable. What does Math Lab want? It wants -3 plus the square root of 21 over 2, comma, and make sure you're away from the answer when you do the comma, that you've used a right arrow to get away from it, -3 minus the square root of 21 all over 2. So if you're doing this in Math Lab, be careful about the placement of your comma. I have known people to make a mistake because they were either right here at the 2 or right at the 21, the square root of 21, and they put their comma in before they got away from that answer. And I don't want you to miss one of these after you've done all this hard work. Okay? A lot of steps. Oh, yeah. All right. More fun. Let's see, how many do we have here? Ugh. Okay, we have more fun. Problem number 4. I have 2x squared plus x equals 6. The instructions tell me to use completing the square. Is it ready for completing the square? No, it's not. Now, it does have the x squared term and the x term on the left. It does have the constant on the right, so that's all good. But what is it that's wrong? The 2. We haven't had one of these before. The coefficient of x squared has to be 1. So if it's not 1, divide by whatever that number is. But if you divide that term by it, you're going to need to divide every term by it. That's going to give me x squared plus, there's an implied 1 right there, so that is 1/2 x equals 6 over 2 is 3. Now is it in the right form? Yes. All right, my steps, take the 1/2, take 1/2 of that, and what will it give you? 1/4. Take the 1/4, square it, and it should give you 1/16. And I guess I kind of forgot to put my blanks up there, so I'll get my blanks ready. So I have x squared plus 1/2 x plus a blank equals 3 plus a blank. And what do I get to put in my blanks? 1/16. Before I go any further, is everybody okay with creating the 1/16? All right, left-hand side. I need to write down the factors. What will they be? X plus 1/4. And please remember that you don't have to do anything spectacular to come up with what number goes in the factor. It's always sitting there. It's not the number you added to both sides, but it is always sitting there. Now the right-hand side. Yes, it's 3 1/16, but you're going to need an improper fraction. So I'm going to go ahead and go off to the side and do that arithmetic. You do it any way you want to. It's 3 over 1 plus 1 over 16. The common denominator is 16. 1 goes into 16 16 times, and 16 times 3 is 48. Plus a 1 gives you what? 49 over 16. the right-hand side is 49 over 16. Square root property, ready to go. What will I get on the left? X plus 1/4 is equal to plus or minus the square roots of 49 over 16. Now, it turns out that very, very frequently the denominator is a perfect square. But in this case, the entire fraction is a perfect square. So this is x plus 1/4 is equal to plus or minus, the square root of 49 is 7, square root of 16 is 4. One more step to get it almost done. Subtract 1/4, and I get x is equal to negative 1/4 plus or minus 7 over 4. Can I do some arithmetic to get the two distinct answers? In other words, can I really do the addition and the subtraction? The answer is yes, I can. There's no radicals, there's no imaginaries. So one of these is negative 1/4 plus positive 7/4, which gives me what? 6/4. And does that reduce? 3 over 2. The other part is negative 1/4 minus 7 over 4. Now they're both negative, so I get negative 8 over 4, which is negative 2. We did a tremendous amount of work on that problem. The fact that I got rational answers, what does that tell you about the original problem? Anything? You could have factored it. It means you could have factored it. All right. Number 5 is more of the same. So I'm going to skip it for right now, and we're going to look at number 6 because I've cheated and seen what kind of answers it has. All right, so we are on problem number 6 because we skipped 5. I have y squared plus 2y plus 10 equals 0. Well, it's not looking too bad. Is it in completely the right format? No, because that constant needs to go to the right-hand side. But at least the coefficient of y squared is a 1. So it's going to be y squared plus 2y is equal to negative 10 when it goes to the other side. So I'll fill in my blanks. Well, at least I'll put some blanks. So I have y squared plus 2y plus a blank is equal to negative 10 plus a blank. Take the coefficient of y, which is a 2. Take half of it. Half of 2 is 1. Square the 1 and you get 1. So I will add 1 to both sides. What will the factors be on the left-hand side? X plus a 1. What will I get on the right-hand side? Negative 9. It's time to use the square root property. That gives us x plus 1 is equal to plus or minus the square roots of negative 9. Oh, I'm so sorry. Yeah, I'm glad you said something because I just kind of made a variable change all on my own. I'm a little partial to x. All right. Do we know anything about the square roots of negative 9? Imaginary. So I'm going to have y plus 1 is equal to plus or minus 3i. Am I done? No, I've got to get y by itself, so subtract 1, and I get y is equal to negative 1 plus or minus 3i. Can I add and subtract these two numbers? No, because one of them's real, one of them's imaginary. This would be absolutely fine for me. My math lab would want -1 plus 3i, comma, -1 minus 3i. So when you get to the point where you have to take the square root using the square root property, that's when you find out what kind of answer you're going to get. Is it going to be rational? Is it going to be complex? Is it going to be irrational? And you never know until right here when it's time to take the square root. All right, let's skip number 7. Once again, it'll be similar. And let's go to number 8, which is pretty much going to involve everything we've done so far. And this will be our last example. I have 4x squared minus 8x plus 41 is equal to 0. This has just about everything bad in it can have. This is not ready for the square root property. I'm sorry, it's not ready for completing the square. What do I need to do? And by the way, the order that I do these two steps doesn't matter. All right. I heard two things at once in class. I heard subtract 41 and I heard divide by 4. You need to do those two things. You can do them in any order you want. You can do them at the same time if you're pretty good. I'm going to go ahead and just subtract 41 because I heard it first. So that's 4x squared minus 8x is equal to -41. Now I'm going to divide by 4. It could have been first. And I get x squared minus 2x is equal to -41 over 4. And we don't start crying just because we've got a fraction in the problem. Yes, we do. So I have x squared minus 2x, I'll put my blank, equals -41 over 4 plus a blank. All right, it's not going to be hard to complete this square because I grab the number -2, I take half of it, which gives me -1. I square the -1 for 1. So I add 1 and I add 1. On the left-hand side, what will the factors be? Will it be x plus 1 or x minus 1? And we'll just remember, there it is, and it always has that sign. Now on the right-hand side, okay, probably it's not a real big deal to you to think about this 1 is the same thing as 4 over 4. I will go ahead and put it over here off to the side, but you probably are more comfortable with this one. It is -41 over 4 plus the 1 becomes 4 over 4. Combining those, that's -37 over 4. It's time for the square root property. That gives us x minus 1 is equal to plus or minus the square roots of -37 over 4. Okay, remember we said that the nature of the answers becomes kind of apparent when you get to right here. Okay, first of all, you can pretty well expect the denominator to be a perfect square. So I know, or at least I feel like, I can go ahead and do that. Instead of the square root of 4, make it be a 2. Now, what do you know about the square root of the square root of -37? It's going to be imaginary, isn't it? I'll just write that. All right, 37. Does it have any perfect square factors? No, 37's a prime. So this is I times the square root of 37, or square root of 37 times I. I did find out yesterday, I tested it, MathLab doesn't care whether the I is in front of a radical or behind a radical. It doesn't care. So this is I times the square root of 37 all over rational 2, and that's x minus 1. So I'm going to add 1 to both sides. That gives me x is equal to 1 plus I times the square root of 37 all over 2. Okay, I messed up. That should be plus or minus. Now, although actually I'd be okay with that as a nice answer on a test, my math lab, and if you were taking a multiple choice test, which you're not, but it would want you to go ahead and get those into one fraction. Do you agree that 1 would be the same thing as 2 over 2? All right, plus or minus I times the square root of 37 over 2. And then we'll go ahead and write the numerator as 2 plus or minus I square root of 37, but we only have to now write a single 2 for the denominator. And then, just so you can have a little bit more fun in typing in your answers in my math lab, it wants them separated. It wants 2 plus I square root 37 over 2, comma, 2 minus I square root of 37 over 2. Is that okay? Completing the square is not usually people's favorite process because it's got so many steps. You got to worry about signs, you got to worry about fractions, radicals, imaginary numbers, get the form of the answer, and so on. Tomorrow we are going to look at a formula that is created by using completing the square and actually could almost replace completing the square, at least as far as solving quadratics. So maybe something sort of good to look at tomorrow. So we'll call it quits on completing the square.